Hello. Yeah, so as Tim mentioned, this is a series of workshops that we've been holding. And the first workshop that we did was a public workshop. And that was really to understand what concerns the public have with AI models and the use of their medical data in training these AI models. And so I thought I'd give you a bit of an overview of that public workshop first. And we had quite a diverse range of members as part of that, from a range of different age ranges and quite a diverse ethnicity as well. So we were able to get a really good view and range of opinions of people's concerns in AI. And we asked them a few questions. The first one's being, how happy would they be with their data being used for AI research? And the majority have said they would be happy with it being used within a trusted research environment. But not many wanted their data being used outside of a trusted research environment. As Simon said, our TREs are very secure. We allow approved researchers access to data in a safe way. And so people really seem to be happy with their data being used within a TRE. And we also asked whether they'd be happy with data being used for just research in general, not including AI. And their opinions were around about the same. But once we went further into the concerns of AI models with them, that started to change slightly. And so we wanted to know what sort of concerns they had with the different data modalities. And as you can see here, we asked them a range of different modalities of data and which they were most concerned about. The most, as you'd expect, is like whole genome sequencing and linked data, wearable data. Imaging data kind of sits around the middle of that, but obviously non-defaced imaging comes higher, whereas defaced imaging is lower and people deem relatively safe. And we also wanted to know what kind of people thought would be most concerning if they would get hold of their data. And at the top, we can see scammers, criminals, insurance companies. So these are the kind of organizations and people that people are really worried about potentially having access to their data. We wanted to know what their concerns were with AI, not specifically with privacy at the beginning, but just in general. And this came to a range of different things, mainly revolving around regulation, trust, bias comes up a lot. Over reliance as well. But regulation, of course, is key to this. But we also wanted to know the positive aspects of AI that people think of. And of course, it's improved healthcare, speed of diagnosis, of treatment, and also reducing bias as well, people said. Then we wanted to know what their concerns specifically were with health data. And this was mainly around having no control of that and the unknown of how that data is being used. And of course, as well, identifiability of their data. So all of these are, very important concerns. But of course, identifiability and privacy and regulation came up quite a lot in the workshop. And of course, that's what we want to concentrate on. And then, of course, the concerns with privacy in AI models as well. And again, identification, regulation, all the following themes, coming up time again. Use of selling data, of course, is a concern to us. We don't do that, but they can see that the risks are associated with their data. And we asked this question at the start and end of the workshop as well, whether they thought AI was good or bad, has its uses. And at the end of the workshop, thankfully, a lot more people thought that AI was good and had its uses. We also held another workshop prior to this one, where we were able to sort of build up an AI privacy risk matrix. You can't really see it here in person, but we were able to build a sort of matrix of scores to assign models, depending on the type of data which was used as that, what sort of privacy preserving techniques were implemented as part of that. So we could really see from the people's opinions and views what sort of data they felt was most concerning and AI models used. So we could assign scores to AI models to deem how risky they potentially were, according to public opinion. But what's the current landscape in regards to regulation and guidelines within the UK? Well, mainly in AI, we have to rely on quite outdated and current laws. Things like bias and discrimination, which came up in the public workshop. That mainly relies on the Equality Act of 2010. And of course, lots of people are worried about regulation not being kept up to date and moving with the fast development of AI. And so that's something that we really saw in the public workshop. And of course, there's other guidelines as well for the use of AI in medical devices and things like that. But a lot of these don't focus too much on privacy. And the UK, of course, released their AI white paper detailing the future landscape and how they want to regulate AI, what should be done. And this covers things like transparency, fairness, accountability, and safety as well. But they also, of course, consider the privacy challenge. And they say that this should be at the heart of consideration for deploying artificial intelligence models. They realize how AI models can be disclosive. They do have privacy concerns. And so they say that this should be at the heart of everything that you do in artificial intelligence, especially when deploying these models. Of course, as well, GDPR has sort of regulated the landscape. We can see from the Information Commissioner's Office, which has guidelines on how we assess security and data minimization in AI. And they talk about certain types of attacks and also privacy observing methods as well for researchers to use. And they also developed a AI risk toolkit, basically just an Excel spreadsheet, where it has all the different GDPR regulations and other laws as well. Again, you can't really see it in person, but there's different criteria for researchers to meet. So this is really to be done at the pre-project stage before you develop your AI, so that researchers can really consider what the potential risks are, and then they have to sort of write how they're going to mitigate against those different concerns. So this can be a useful way for assessing a model at the pre-project stage, sort of determine if researchers have considered all these different types of scenarios. And the Ada Lovelace Institute actually developed something similar, the algorithmic impact assessment, which again asks similar sorts of questions, but this was developed specifically for the NHS AI lab, and specifically for their imaging platform as well. So we can see that this has already started to be thought about by these different organizations, and imaging, of course, is of a concern in this. But these are just ways for, at the pre-project stage, to assess if researchers have taken into consideration these things. There's nothing at the end of it to assess these AI models. And of course, genomics as well is something that they've considered as being, a more difficult privacy concern, as it's more difficult to anonymize. It can be, highly revealing. So with DeepUK, we have a lot of neuroimaging and genomic data. And so that's why we're really here today to discuss these concerns with neuroimaging and genomic data and the effect these have with disclosiveness, as well as other modalities of data as well. And there was a Dare UK for the grey matter report as well, specifically for disclosure control for trusted research environments. And this sort of identified the certain risk types for AI models, and again, went into detail about various attacks and how privacy can be preserved within those attacks. We've got Jim giving a talk later on the assessment of AI models, and he was very heavily involved in this report, and we'll discuss a lot more further in detail of that. So why should we be worrying about AI models potentially revealing privacy? All of our data is anonymized, right? We remove names, we remove disclosive information from that data. So if that data gets out, why do we need to worry? Well, there's this statistical model developed from Imperial, where you're able to give, I think, 6 different attributes, such as your gender, marital status, date of birth, work class, and it would then be able to determine your risk of being identified in an anonymous data set in the world. And you can see here the identification chance of certain different combined variables together. So if you combined your gender with postcode, your date of birth, all this kind of stuff, then there's a very high risk of actually being identified. If you remove things like postcode or date of birth and things like that, then it really reduces to basically 0% if you don't have postcode or date of birth. And we remove this kind of data from data sets, but once you have in cohort data where you have lots of different columns and lots of different variables collected about people, then putting that together, you can pretty much be able to identify people. Here, you can't see very well, but it's a comparison showing how different attributes can really have a significant effect. So here there's put in data from just a standard individual without their postcode, with the marital status of never married, and their percent of being identified was only 2%, so very low risk of being identified. if you change that marital status from married to same-sex partnership, that risk increased to 82%. So going from 2% to 82% just from that change in one variable just really highlights how underrepresented groups, minorities, people with rare conditions can really be impacted through identifiability and privacy. In the UK, a standard white male individual might not, have a very low risk of being identified, but someone with a rare condition or, in an ethnic minority, then their chances of being identified, significantly increases. So, once you consider kind of data collected in cohort studies, people's, whether they smoke, their education level, lots of different things, this combined could potentially identify people. And so there's lots of different attacks and vulnerabilities that we need to be concerned within AI models. And I'll go through some of these in more detail over the next few slides. But you can see there's a wide range of different attacks which can be used to potentially reveal information from AI models. But not even attacks, there's certain vulnerabilities in AI models or just even the type of model that you use, which could potentially reveal information. So Simon said, Deep UK as a trusted research environment is very secure. We only allow approved researchers access to that data, approved projects, and we only give them the variables that they need to do their project. And they're never allowed to bring that data out of the portal. If they have any results that they want to bring out, like graphs or tables, that goes through our file out review, where we basically just have 2 reviewers to check there's nothing identifiable within that data. AI models, of course, is a lot more difficult to be able to do this. A lot of them are just black boxes. You can't open it up like a file of a graph. You don't know what's in the AI model, how it's been trained, how it works, what it does. And so that's why we really need to consider the risk of AI models and how we can assess them. That's what's important to us, assessing these AI models, so that we can be sure that they're safe to release and don't reveal any private information. So, someone in our platform might use a range of questionnaire data, neuroimaging, genomics to develop some sort of treatment response model. And that might give us a classification of whether something's going to be effective or not effective, just a binary classification. And then a confidence score as well. So it might be 78% confident in this case. Now, one of the types of attacks is a membership inference attack. And this basically allows an attacker to reveal whether a certain participant was a member of the training set in that data. And so this kind of works by an attacker building up a shadow data set. So they might know certain features of the data set which was used. They might know the variables that was used in that model, but they don't know the data. The data, of course, is in the TRE. No one knows that data, but they might know the features of that data. And so they can sort of build up a shadow data set with just random values of those different features to then create a shadow data set. And of course, this makes it a lot easier when people publish their AI models on something like GitHub, and they explain their techniques of how it's been used, what was the data used to train the model, how someone could potentially use the model themselves. It's being increasingly encouraged in the field for people to be able to do this for reproducibility reasons and things like that. So oftentimes there will be detailed steps of how these AI models work and what the data was. And this is very helpful information to an attacker to be able to use to be able to potentially attack a model. From this shadow data set, they then are able to create a shadow model, and they might create several of these shadow models. So they, if they have the released AI model, they'll know how it works, they'll know the parameters maybe. And so they'll be able to build these shadow models, which basically are similar to the original model. And from this, they're able to create an attack data set. Basically, from this by showing whether training data is in or out of the model, whether it's a member or not. And from this attack, they're then able to build, from the data set, sorry, they're then able to build these attack models, one for each classification, which is then able to determine whether someone is a member within that class. And then, of course, they can probe the original model with a certain subject and potentially reveal whether that subject was part of the training set. And so, you might wonder about the motivations of doing this. There's obviously political motivations. If a politician had dementia and it wasn't in the public domain, and someone was able to probe a data set in this way and reveal that that individual was used to train a dementia model, then obviously that person has dementia and they're able to reveal that information, something which wouldn't have been in the public domain. And then you have an attribute inference attack as well. So again, similar, someone might develop a dementia diagnosis model. And this allows an attacker to basically get unknown variables about an individual that they might already know. So somebody might already know data such as their age, their gender, potentially their, whether they have depression or not. And from this, they're able to use the attributes they know with random combinations of the variables that they don't know to be able to probe the model to then reveal if what the unknown variables are about that person. So obviously AI models, the higher the confidence value, the higher it's more likely to be an actual individual within that data. If you get a confidence value of something like 98%, then it's probably likely that that person was used to train the model. Usually you'd get something like 70, 80%. So this can really be exploited, this confidence score can really be exploited to reveal people in that training data set. And then you have things like model inversion attacks. And this is a very concerning attack because it's able to basically recreate the training data set which was used to train that model. And this has been demonstrated a lot in imaging data. So you can create a generative model to be able to generate maybe synthetic brain imaging scans, to be able to then query the model, the release model with these scans, and have that generative model change the scans each time until it increases that confidence score, until it's so high, until it's like 98, 99%. Then at that point, it's very likely that that scan was actually used to train in the data set. But of course, there's these different types of attacks, and there's certain things which make these attacks more likely. Explainability is one of those things. Again, this is something that's really encouraged in the field. As I say, AI models are black boxes. We need explainability, especially if it's being used in a clinical context. We need it to be able to explain how these models work. But from the information that these reveal, it can make it easier for an attacker to attack a model and find out information about an individual. And this has been raised before with the Information Commissioner's Office and other organizations. So, you really need to think about the type of explainability that you use in your AI models. Overfitting as well, of course, is a problem. If you have a model which is memorizing the training data set, then that, one, makes it a lot easier to attack, but two, the AI model itself might be able to reveal information about an individual just from the way it's trained, because it's overfit on the data and it's been able to memorize specific instances within that data set. And instance-based models as well. So these are the most concerning type of models because they actually contain data. They basically use the data as the AI model. They basically use the training instances to be able to determine if, when there's new instance, how similar it is to those training instances, the data. So this type of model by the Information Commissioner's Office actually is considered, if you transfer this model, then it's a transfer of data, because the model itself is basically data. It uses the data to learn its training data sets. So these kind of models would probably not be allowed out of trusted research environments at all, because of their nature. And we started thinking as well, maybe it's not just attacks on models that we need to be worried about releasing. Maybe we need to be concerned about people bringing AI models into the platform as well, bringing pre-trained models in. There's been, research articles mentioning things like using functional MRI scans and in combination with large language models to decode people's thoughts. And, obviously this isn't too much of a concern now, but do we need to assess people bringing in AI models into the platform? And, what sort of things would they be used for? Large language models, of course, is something which has grown rapidly over the past year. And so this is also another consideration as well.